So we're almost done with these. So today we're going to talk about solving equations now when you have rational expressions. So you'll see here today we're just going to have one fraction equals another fraction. That's all we're going to have. Now, to actually solve this, this is actually going to be pretty easy. We're just going to cross multiply. So I'm going to multiply these together and I'm going to multiply those ones together. So if I start with, interesting, if I start with multiplying these two together, not going to work for me, are you? Let's try that again. If I start with multiplying those two together, I just have to multiply by 1. So I'm going to get x squared minus x. And then remember, in between your cross multiplication, you put an equal. Now I'm going to take the 2 times this stuff, which means I have to multiply through by 2. So I have to multiply both of them by 2. So we get 2x minus 2. And then we go ahead and get everything equal to 0. So I'm going to subtract 2x from both sides. I'm going to add 2 to both sides. So then I get x squared minus 3x plus 2 equals 0. And so now we've got a double bubble problem that we need to solve. And remember, since it's equal to 0, we can actually do the double bubble and set those equal to 0. So if you need to, use the box. So we've got x squared and 2. That would be x and x, 2 and 1. And then if they're both negative, that would give me a positive 2 in the box there, but it would also give me a negative 3x in the middle. So my bubbles are x minus 2 and x minus 1. So then we go ahead and solve. X minus 2 equals 0 and x minus 1 equals 0. Add 2 to both sides. X equals 2. Add 1 to both sides. X equals 1. Now here's where it gets a little bit tricky. Let's go back and look at our original problem. Now, if x equals 2, that's going to be okay, because 2 squared is 4, and then if I plug in 2, 4 minus 2 is 2. That works out. What I'm worried about is, what if I got 0 on the bottom? Or if I plug in a 2 here, 2 minus 1 is 1. So that's okay, I don't get 0 on the bottom. However, if I look at my x equals 1, if I were to plug in 1 right here, 1 minus 1 is 0, and all of a sudden I've got a 0 on the bottom. I can't have that. So x equals 1 is not an answer, just x equals 2. Remember, that's called an extraneous solution when that happens. So let's try another problem. Here I'll start by multiplying the 1 times the bottom there, so I just get x squared plus 4x equals, and then I'm going to take 3 times the bottom, so 3 times x is 3x, and 3 times 4 is 12. And then it's just like back in chapter 5, we're going to get everything to one side, so I subtract 3x from both sides. I subtract 12 from both sides. So now we have x squared plus x minus 12 equals 0. Okay, now I'm looking at double bubble. So if you want to use a box, great. If not, that's fine too, as long as you know what you're doing. 3 times 4 gives me 12. It'll be a minus 3 and a plus 4. So now I take each bubble and set it equal to 0 and solve. So I add 3, x equals 3. I subtract 4, x equals negative 4. And now I'm double checking for any zeros on the bottom. If I take and if I plug in 3 on the bottom, that'll work out. 3 squared is 9. 3 times 4 is 12. 9 plus 12 is something, not 0. And then 3 plus 4 is 7, not 0. So 3 is okay. But if I plug in negative 4, notice negative 4 plus 4 is 0. That means negative 4 cannot be an answer, just x equals 3. Alright, I think this is going to be my last one. Yep, this is my last one. Alright, so let's do this one more time. Let's get a good color in here. I don't know, let's go for some green maybe. Alright. Oh, for fun, look at what I get to do. I get to take x minus 2 times 2x squared plus 2x. This definitely calls for a box. So we have 2x squared plus 2x times x minus 2. Oh, for fun. Okay, so now what I'm going to do is I'm going to have 2x cubed and then 2x squared and negative 4x squared and, oh gosh, what is that? Negative 4x. Oh, I don't want to do it that way. I wonder if there's something else I can do. What if I took out a 2x on the bottom here. If I did that, I would get x plus 1. Now notice I have an x plus 1 here, and there's an x plus 1 here. Think in common denominator. Let's see what that does for us. If we were to get a common denominator, so that means what I need to do is multiply top and bottom by 2x. So I'm changing up how we're doing this, by the way. Okay? So now on the left, I have 6 over 2x times x plus 1. And on the right, I have 2x squared minus 4x over 2x times x plus 1. Now here's what benefit you have for getting a common denominator. And we're actually going to use this more tomorrow. But here's the benefit. You have an equal sign right here. That's a big deal. You have an equal sign. That means this fraction equals this fraction. Well, because I have a common denominator, the bottoms are already equal. So what I need to focus on is that the top is equal. So I'm actually going to just disregard the bottom right now and just write out the top. I'm going to move the 6 over. So then 0 equals 2x squared minus 4x minus 6. And then it's a double bubble time, but before I double bubble, I'm going to factor out a 2, because that'll make double bubble easier for me. Okay, so that means now I have a 2 times my double bubble equal to 0. My double bubble would be a 3 and a 1, negative 3, positive 1. Okay, so now as I'm looking at setting things equal to 0, if I took that 2 and set it equal to 0, it's not possible for that to happen. So ultimately we can kind of ignore the 2. But the rest of it I need to set equal to 0 and solve. So then I get x equals 3 and x equals negative 1. Going back to my very original problem, if x equaled 3, that would be fine. I can plug in 3's and I'm good. But if x equaled negative 1, I've got a problem right here, right? Because I've got negative 1 plus 1 gives me 0. So x cannot equal negative 1, x just equals 3. So just to recap, you can do one of two things. When you have a problem, you can cross multiply and then see where you go from there. However, every once in a while when you do that, you're going to start getting crazy things like 2x cubed. And so what you might want to do is go back, and instead of cross multiplying, you might want to just get a common denominator so that then you can just take the top and set it equal to each other.
Mhm.